My name is Christine Richards, and I will be the moderator for today's panel, and I'm also the research director for Zpryme. So the panel we have this morning is called Futuristic Grid, and with this panel, what we're really looking to do is talk about the path to really move from scientific discovery to the marketplace and really start to build a more advanced grid. We had some great announcements by Argonne this morning about 2 new centers that are opening up, the Nano Design Works, or NDW, and the Argonne Collaborative Center for Energy Storage Science. So we wanted to use that really as a springboard to talk about some of the changes that are going on in the industry and where we can use some technology to help move the utility industry forward. And we have 3 very qualified panelists here from Argonne to handle this discussion. And the bios are in the agenda, so I'm just going to give a quick review of their name, title, and then we'll get into some questions. So first of all, we have Dr. Andreas Roelofs, who is the Director of Nano Design Works with Argonne. Thank you for joining us.
Thank you.
We also have, let me move around on my right spot on my page, Leah Gazowski, who is the Director of Strategy and Research Program with Argonne. Thank you for joining us.
Thank you.
And we also have Dr. Seth Snyder, who is the leader for Water, Energy, and Sustainability at Argonne. So thank you for joining us as well.
Thank you.
All right, well, let's go ahead and really, I think, Argonne, a lot happening in that area, a lot of different things going on. It'd be great to, first of all, hear a little bit about your role at Argonne and really summarize, the way that your group within Argonne is really helping speed that discovery to marketplace that we've been talking about. Andreas?
All right, so maybe I talk briefly about Nano Design Works and maybe also about Access, because we had somebody else that wants to be on the panel but that couldn't come, Jeff Chamberlain, who is the director of Access. So at Argonne, we have a lot going on in Nanoscience. So there's a center that has about 90 people working just on Nanoscience. And there's across Argonne many more people that work in that area. And Nanoscience is actually going to change the world, I believe. There's things you can believe. We have shown that you can attack brain cancer cells with nanoparticles and only attack those and leave the healthy cells alone. You can think of gearboxes that don't need oil, that have diamond and graphene in it, that make this frictionless. So there's a lot of these ideas that have been published in journals, but if they just stay in journals, then you never see the benefit of that. And that's really what we announced this morning at 8:30. We had a press release where we said we are creating 2 new centers, Nano Design Works and Access, where we're going to open up the doors a little bit wider than they were before and try to pull in industry. Because in the National Lab, we don't manufacture, right? Our mission is science, but we want to get industry in and get them excited and hand some of these ideas over to them that they get into products. That's really the high-level thing of what we are trying to do with these 2 new centers.
Excellent, excellent. Leah?
Sure. So when I started thinking about this question, I broke it down into really 3 pieces in terms of how we engage industry and outside entities outside of Argonne National Lab. I think the first is really just to listen, to hear what's going on, hear what the industry needs are, and try to identify how our science and engineering can contribute to those needs. I think the second is to really come up with strong plans at the laboratory on teaming. So I can't emphasize that enough. Teaming is a critical part to what we do, and that's what we want to see more of, and that's why we're building the centers that we are, and that's why we're especially happy to be here, is to develop new teaming partners in our work. And then the third is to talk about Argonne National Lab. How many of you are familiar with the lab or have been to the lab? Okay. Of course, my colleagues here, I hope.
Yeah, sorry.
I think just to step back a little bit and give kind of an overview of Argonne National Laboratory. It is one of 17 national labs throughout the country. We're a Department of Energy national laboratory doing both basic and applied science research. One of the key features of the lab is our user facilities. So we have 5 user facilities. So for example, we have high performance computing capabilities at the laboratory is one of them. I think to put that into some kind of context, I like the example that if every man, woman, and child on the Earth did 1 calculation per second for the next 17 days, it would take what our computer would take 1 second to do. And we just recently announced a new computer that will come online in a couple of years that will be 18 times faster. So those are the kind of capabilities that we have. We're about 1,400 scientists and engineers at the lab, and we're doing a lot of new initiatives at the lab. So you heard a little bit about some of our initiatives in energy storage and in nanoscience. But we're also doing very interesting initiatives in resilient infrastructure and how to make the US infrastructure more resilient to both natural and man-made events. We're also looking at system sciences. So how do we look at cities and actually look at them from a more systemic perspective? And then lastly, I'll mention our work in the grid modernization. So we're doing a lot of work around modeling and making our grid ready and capable for the needs of the future. So I'll talk more about those things today, and thanks again, Christine, for the opportunity to be here.
Excellent, thank you. Seth?
First of all, why is somebody who's here talking about water on a grid panel? We think of energy in the US and we use almost 20 million barrels a day of oil. But when we look at water, we actually use closer to 8 billion barrels a day of water in the US. That's how much withdrawal we do. So it's 400 times larger water versus oil. But what does that have to do with the grid? The single largest reason we withdraw water in the US is for cooling power plants. Thermoelectric cooling is the largest demand for water. So if you talk about a reliable grid in the US or anywhere in the world, you need a reliable water supply. So they're very, very interlinked, and we've called that the energy-water nexus. So we're taking two tracks at Argonne. One is a Department of Energy national lab team, and there's, I think, 13 of the 17 labs are working together on the energy-water nexus. We've produced roadmaps. We produced a plan for the Secretary of Energy, and the Secretary is very interested in it. I'll be going in a week and a half to a workshop that they have in Washington. There's basically, we say, a reliable power and reliable energy requires reliable water system. It takes a couple tracks. One is, how do we use water more efficiently? And another track is, how can we reclaim and reuse water? And a third track is, how do we use less energy to deliver the water we need? And we're working down all three tracks. And thinking about how do we create this as a business opportunity, go beyond the researchers, what I think this panel is talking about. One of the things I'm doing is I'm working with the local business community. We're in the suburbs of Chicago. Chicago's a big industrial city. I've in the process of forming, and it will be announced sometime this fall, a center that will be called Current, C-U-R-R-E-N-T, and that is between Argonne, the local business development community, and the regional universities to address these questions on energy water. So we're there to take the science and the engineering coming out of the research universities, the research institutions like Argonne, and bring it to the business community. And by the business community, that will include the investors, it will include the big technology companies, as well as companies like architecture firms and energy services firms. So that's exactly what we're trying to do, which is to bring the technologies that are needed for a reliable grid to the marketplace. And I'll give one quick example. Some of the work I've done in the lab at Argonne is on water reclamation and how to do it more efficiently and recover energy at the same time. Argonne has allowed me to actually form a spin-off company on that. The company's called Add Up Energy. And while I'm sitting here on my day job speaking here at this panel, I'm also working and looking to investors to get Add Up Energy launched, and that would actually directly direct the important questions in terms of water availability and water reuse, and it's a benefit back to Argonne because Argonne would benefit from any success of the company.
And do you want to take a little bit, a moment, Seth, there to expand on, I mean, we have these national labs, a lot of research going on there, but there's also a lot of private industry involvement and experience that people at Argonne have. Do you want to take a moment just to talk about that a little bit more in terms of some of the private industry experience that you bring to the table?
We work with big companies and small companies. I have done publicly announced project with ADM, Archer Daniels Midland, and bioprocessing. I've done projects with Nalco, which is now part of Ecolab. I've done projects with BP, all having to do with energy and water. So these are big, well-known companies. We've also worked with a lot of small companies. A lot of times that will be where the company actually gets some of Department of Energy research. Sometimes the big companies will directly fund the research if it's directly along their business line. If it's more enabling, then it'll be a partnership with Department of Energy funding. We do both. And it's a more recent phenomenon that was saying, if this is really valuable technology coming to the lab, can we create our own spin-off company? So I'm a little bit of a guinea pig here, trying to say that I'm going to still wear my Argonne hat and try to take this to marketplace at the same time. But I've done projects where it was 100% privately funded and projects that were 80% public funded, you know, where the industrial partner basically, they put their in-kind in to move it forward. It's almost, I wouldn't say almost, so it's always aligned with their business interests, and it's aligned with the interests of the Department of Energy. So we look for projects that would benefit society, and then the company would actually have an opportunity to generate revenue and it'd be a value proposition for them at the same time.
Yeah, maybe I want to add to this. So Leah had mentioned the user facilities at Argonne, and that is an interesting place that attracts a lot of companies. And these user facilities, there is one mechanism where if a company wants to do science, they have scientific challenges, they're working not maybe now on a product that's in the market, but they're working on ideas that are 5 to 10 years out. They can come to Argonne, propose that research in a two-pager basically, and then they can access that user facility for free. So I was on that side. So I worked in a Forge 500 company on new memory, and there's what is called a light source. The advanced photon source gives you hard X-ray, and you can look inside of devices like CPU chips or memories. And so from Seagate, I wrote a proposal with my colleagues, and we were allowed to use that facility, which is roughly $1 billion, the light source, and we could look into our memory while it operates and watch how it operates and how it actually failed at the end. So that was the sad part. But so in principle, you can, without money, also access national labs through that user facility. And then often that goes to the point where people see what are the other capabilities. And then if you want to do proprietary research, then we have to charge cost recovery. But there's a huge asset of facilities that you can actually use for free.
And in support of Andreas, it's not just the instrument itself, but the expertise of the scientists who run it and develop the technologies, that you have access to both.
Yeah, good point.
Sure, I'll add in. I think Seth did a nice job of highlighting the range of work that we do with private industry and the different mechanisms that we have to work. I'll add in another example that we recently worked on, and that was to develop a city-scale simulation tool. So we started working with urban planners and developers, and what we learned from talking to them was that they really didn't have a very good way of putting together the different systems within a city and actually have a way to simulate and model those different systems. So it was a specific example of a site on the southeast side of Chicago. It's called Lakeside. It's 600 acres. And they really the developers came to us with two problems. One was we don't really understand how to work at a 600-acre scale. And then the second is we don't really have a very good way to understand the interdependencies between the different systems within a site. So for example, with water, transportation, buildings. So what we were able to do was we took some of the work that we had completed with Department of Energy research funding that looked at uncertainty quantification of building energy demand. And then we actually started putting that into a common platform that we were then able to link it with our agent-based modeling in transportation. And we're looking to build out that model in a way that we can get to a more comprehensive view of what cities look like. So another example of, we took some initial funding, and then we were actually able to take it and work with a private firm who then funded us to do this type of work.
Excellent. Yeah, I mean, it sounds like there are just so many opportunities and connections that are taking place. Now, one thing that we wanted to cover in this panel was really looking at the utility industry and what's happening in that space. We've seen smart grid, smart meters, I mean, all of these things that are happening. And it's gone from just smart meters to, now we're talking about nanoscience and all these different things that can play into the utility industry. So if each of you could take a moment to talk about, for the utility industry specifically, where are you seeing technologies within Argonne that can apply to that and how it applies, that would be great to hear that.
So nano is, I think, also very, very broad. So when I start talking about nano, grid is not the first thing that comes to mind, right? But what nano materials do, if you look at the materials you have today, everything around you is made from materials that you find on the periodic table of elements, right? And nano gives that a third dimension. If you take materials and you scale them down, people heard about carbon nanotubes, right? That's just carbon in this tiny form, but the electric conductivity of that material is extremely high. So if you combine, for example, copper with that material, you can envision making new materials that are better thermal conductors and better electrical conductors. So there could be new materials made for, delivering electricity. The other big piece, which is still a problem, is switches. To switch large power of electronics, they're called wideband semiconductors, to switch from alternating current to DC current or vice versa. If you have an electric car, you have solar panels or anything like this, where you have where you produce DC current and you want to put it into the grid, you have to actually switch that very fast. So you can use diamond films and make diamond electronics and create better switches. So there's a whole vast of ideas out there, but nothing is really on that scale yet on the grid. But again, I think the third one I want to mention is for sensing. So there's some novel applications where you can use nanomaterials for creating great sensors into the grid, I think.
Great.
Sure. So in terms of, if we start thinking about the future of the grid, many projections put it at about a $300 to $500 million investment over the next 20 years. So I think it's fair to say that we probably aren't going to do the exact future of the grid any kind of justice this morning, but we'll try. I think the first thing to realize is that we're operating under a very different technology and organizational architecture of the grid today than we will in the future. And I think a lot of that comes from looking at what we can see changing. So we think that distributed generation will be coming online. Clearly, the electrification of the transportation sector is a factor. I think that, as Andreas said, sensing, we're definitely living in a more information-rich society, and we're also living in a way that consumers are starting to expect more interaction with the grid. That will change things considerably. So all that said, what are kind of the key game changers here? Well, we have to go back to storage. And I think my colleague who couldn't be here today, Jeff Chamberlain, would echo that. We're working very hard at the lab to get to a goal where we can actually create energy storage options for about $100 per kilowatt hour. We think that would be a game changer, both for the grid and for transportation. And I think once we actually reach the goals that we have with energy storage with industry partners, then we'll start to see options where you can start talking about things like virtual power plants, and you can start thinking about how do we take different sources of energy and use them in a way that is favorable with the technology that we have, and then also with what consumers expect and are looking for in other industries as well.
Excellent. Great. And Seth?
Okay. As I said before, the reliable grid requires reliable water. We've had cases where with warm temperatures has caused us to take thermoelectric power offline nuclear plants in the southeast. So where we see is critical is that we work directly with the utilities, and I have actually a meeting with a utility company tomorrow afternoon. They want to keep up with what is the best water technologies. So at a Department of Energy level, we're doing both modeling and treatment technologies. I come from the treatment side, the technology side, rather than the modeling side, but they're interested in both. Water reuse is seen as a huge opportunity for the utilities to basically continue to deliver reliable power while reducing their environmental impact. So as we see tighter and tighter water supply availability, we see more and more interest in how do we reuse water, how can we recirculate water, and to do that requires technology. It may require membrane technology or anti-scaling technology, and those are the kind of areas that we work in directly. Can we make a membrane system that will last because we have better materials, maybe developed by Andreas. So we work with actually people from Andreas' team to make better surfaces on membranes, not Andreas directly, but so that we can do that. And ultimately, the customer for all work in water will be the utility industry. I mean, we think of, if you go to your next door neighbor and you ask them how to save water, and they'll talk about taking a shorter shower, the way to save water is to reduce your energy use, and specifically your power use, and also, so it is very, very interlinked. So it is a question of utilities want to maintain the right environmental footprint for their sustainability goals as well as their regulatory goals, and they're looking for the best available technology to reduce and manage their water. We're talking about things like fit for use and water chaining. Have people heard of fit for use? Fit for use basically means that I'm going to use water at the quality I need it. I'm not going to treat it, over-treat it. I don't need potable water necessarily for cooling application. So if I get it to the requirement that is needed, that actually reduces the overall cost and the energy use. And so I only produce that highest quality water for the highest quality needs. And that's where we get into chaining. If I have 3 or 4 operations that need water, I'll clean up the water, use it for the highest quality water in the first application. The discharge from that becomes used for the second one. So that's a design question, it's a treatment technology, and ultimately what it will deliver is a more reliable power grid.
Excellent, excellent. Yeah, I mean, there are just so many changes happening right now. Now, we have a few minutes left here, so we want to open it up for questions. And I know that you can submit questions via slido.com, or you can come up to our wonderful microphone over here and ask your question, or you can just raise your hand and let us know. So what questions are out there? We really want to hear from you all.
And don't be shy.
Don't be shy. Oh, okay.
Can you use the mic?
Utility scale battery system for scaling up to the gigawatt.
Batteries. The best batteries. Jeff, would you answer the question? Oh, Jeff's not here.
Yeah, the person who is really the energy storage expert, he wasn't able to make it today because of a family emergency. But it's something that we can definitely do.
No, we can get the answer to you. It's something where when you're looking for what is that technology, it's probably not going to be. I can tell you what it's not going to be. It's not going to be what is in your cell phone. That is not going to be the battery. But what exactly it is and what the best bet is, that would be Jeff Chamberlain probably answering the question.
And one other direction that we could point you in. We do quite a bit of work in partnership with an organization called the Energy Foundry in the city of Chicago, and they are working very closely with a startup that is working on utility scale solar. And I cannot recall the name of that company right now, and I apologize for that, but we can certainly get that to you, and we can connect you with our colleagues at the Energy Foundry and with this startup who is working in utility scale storage.
All right. And then the next question we have up there is, do you see the current utility structure, essentially a regulated monopoly, as a barrier to the implementation of technology? What are your perspectives on that?
If it's perceived as a cost, it could be, but I mean, I can't make a decision for a big company, and my manager's telling me not to.
Yeah, so I mean, and I'll add to that too. Certainly there's a regulatory and policy aspect to all of this, which is, in my own opinion, a very key component of this. Our focus is really on the science and engineering and the technology, but I do think that suffice to say that there are to move into the future grid that we're talking about, there are some significant regulatory changes that would likely be made.
One of the discussions we always have around technology is, will it be implemented if there was absolutely no regulations? Does it make enough economic sense? So that actually is our goal on most technologies. Where is it going to be a replacement technology without requiring it from a regulatory side? So that's what we aim for.
In some ways, I mean, I think that the technology in some ways is further ahead. We need policy in this country to keep up with the technology and the direction that we see as critical, especially with regard to carbon emissions.
I mean, I think that's something that we're definitely seeing just more broadly in the utility industry, is that regulatory model has definitely, it focuses a lot on investing in physical assets. That's how a lot of utility companies are incentivized. And so it's kind of that changing model where now, companies are looking at more technologies and services, and these are not things that they were typically able to recover their costs on. So, but a lot of utilities are really starting to question those business models. The PUCs, the regulatory commissions are starting to look at them differently, but it's definitely going to take a little bit to make those sorts of changes. Okay, other questions? Yeah.
How long until we see $100 per kilowatt hour storage?
Yeah, I can't speculate and say on that one. It's certainly an aspirational goal. We have all sorts of folks at the lab right now who are working towards that goal, but we know it's a difficult goal, it's a challenging goal. But I think to speculate on the time frame might be a bit premature, but obviously, we take things sooner the better, but I can't give you an exact time frame for that.
Yeah, there's definitely so much change going on in energy storage right now, but yeah, there are definitely some exciting things happening. Yes?
What do you think of Tesla and Mercedes bringing out energy blocks for the residents primarily? How's that going?
Maybe if I start, I'm talking now from me as a private person. I think that is exactly the idea, a great idea. If you have solar panels on your house, you have your battery in your garage. Some areas, the cost of electricity is changing day versus night. So where you could charge up your batteries over daytime when electricity is more expensive and then use it at night when it's cheaper. So I think that could be very transformative. And then also the business model is the question when people start putting business models in place where you actually don't own that battery, you don't own that solar panel, you actually lease that, and it lowers immediately your bill. So I actually started looking into that, doing that at my private house. So I think that could be a great start.
I mean, there is some in terms of load stabilization, frequency stabilization. There are benefits back that you can monetize it that way too.
I think that what they're doing, we need those kind of innovators to be putting these things out here and get consumers excited. I also think that these are all moves to be able to, I think what Seth is talking about is to move to a more transactive energy system. The one thing I think is really important for us to think about as we move to these things is then what are we displacing, right? So we saw that was very interesting in Germany, where you do have, you're looking at more around 32 cents a kilowatt hour, where here you're, 7 in Chicago. But when you put in storage and high solar capacity, you're displacing things like pumped storage hydro. And is that what, these are all just question marks that there's not necessarily a right or wrong, but all of the trade-offs when we do these things are just something that we want to think through and understand the impact. I'd say similar story for nuclear in Illinois, where we actually started seeing negative pricing given more renewables coming online. Is that really the intended outcome? I mean, that's a whole nother discussion and talk.
Okay, awesome. Well, I'm told that we are out of time. A lot of good questions here. I think a lot of good conversations are going to happen throughout the day. So please join me in thanking our panelists here. That was wonderful.